Okay guys, sorry I couldn't be here with you today, but I thought I would go through this lesson with you, reducing expressions, and so you have something to watch and figure it out. So follow along with me. I hope you have the note printed out, and we'll start at the top. Reducing expressions, you can reduce an expression by dividing the top and bottom of a fraction by the same thing. And I'm going to add to that, it's the same factor. So we're looking for common factors that we can actually reduce by dividing. We'll start with this expression here. 2 times 5 divided by 2, well, the answer obviously is 10 divided by 2, or 5. So yes, you can reduce. And the actual value is 10 divided by 2, which is 5. Does it reduce? Absolutely. You're allowed to do that because 2 is a factor on the top and the bottom. Second expression, 2 plus 7 divided by 2. Well, 2 is not technically a factor on the top. It's being added with 7. And so if I tried to cancel the 2's, the answer would be 1 plus 7, which is 8. But what's the actual value? 7 plus 2 is 9 divided by 2, or 4.5. So no, that does not work at all. Same reasoning for the second one, or the third one here. I cannot reduce 2 and 2, because then I get 1 over negative 2. But what's the actual answer here? 2 over 2 minus 3 is 2 over negative 1. This one, even though you think it looks the same, is 1/2 the same as 2 over 1? Absolutely not. So no. Fourth one. Is 2 a factor on the top and the bottom? Well, if it's being multiplied into a bracket, then absolutely it is. We can cancel those 2's and get an answer. 9 plus 3 is 12 over 7. And you get the same answer here of 12 over 7, whether you double the 2 on the top and bottom. Last question, 2 times 5 plus 3 in the numerator, 2 times 2 in the denominator. It looks like there is a factor of 2, but remember, this numerator is a package deal. You cannot do anything factoring or reducing wise if you have an addition on the top, 2 times 5 plus 3. The only way you could figure this one out is if this was a factor of 2, so like 6, for example, or 10 or 12. Then you can factor a 2 out. But right now, the way it's written, that is a big no. This one, sorry, was a yes. Okay? I'll let you write your own conclusion to that. We're looking for factors that are being multiplied, and if you see an addition or subtraction, watch out, because those represent package deals. This 2 plus 7 is actually in brackets. This 2 minus 3 is actually in brackets. Question number 2. It says to reduce each of the following expressions. Well, the reasoning stands from above that I cannot cross out things that are equivalent here or reduce. So for example, I cannot cancel the 12 and the negative 16 the way they're written. I have to find factors first. So, let's factor the top. X cubed plus 3x squared plus 4x plus 12. And what I immediately notice about these 4 terms is that I can make 2 groups out of them and common factor something out of each group so that I get the same binomial left over. Interesting. So I can take x squared out of the first 2, factor out x squared. I'm left with x plus 3. And I can factor out 4 from the next group, leaving me with x plus 3. Well, that's convenient because that means we don't need to use the factor theorem here. It's just x plus 3 times x squared plus 4. Let's do the same thing to the bottom. Let's factor the bottom. Find out what its factors are. Here we have x to the 4 minus 16. this looks to me like a difference of squares. That's a perfect square, that's a perfect square, it's a difference. So we can factor it as such. X squared plus 4 times x squared minus 4. And I'm looking at these two results, these two factors, and thinking to myself, is this factored fully? I don't think so, because this is another difference of squares. Is this a difference of squares? No, because it's a sum. We cannot factor this one any further. However, we can factor x squared minus 4 into x plus 2 times x minus 2. Okay, so going back to my original question over here, I see that the answer here should be, on the top, x plus 3 times x squared plus 4, that's what we factored the top to, divided by x squared plus 4 times x plus 2 times x minus 2. And now that we have everything factored, we can actually look at this and say, are there any factors on the top and the bottom that would give us the exact same answer? And I'm looking at this factor here, x squared plus 4, and that factor there. They're going to give me the exact same answer. So if I divide the top and the bottom of this fraction by x squared plus 4, guess what? They reduce. Is there anything else I can reduce here? No, because these factors will not give me the same answer. Okay, so the answer must be x plus 3 all over x plus 2 times x minus 2. Don't forget about your restrictions. This is a rational function, and originally it said x squared plus 4 times x plus 2 times x minus 2. X cannot equal here negative 2, positive 2, and from this, well, I'll talk about that in a second, it cannot equal plus or minus 2. X squared cannot equal negative 4. X cannot equal the square root of negative 4, but that's not even possible. So we don't need to worry about that restriction at all. Last one on this page, I see 5 to the 3x minus 5 to the 4x divided by 5 to the 5x. These, as they're written, are not common. Same base, but different exponents. How can we make this common, or is there a way to help us reduce this? Let's find out. Here we have 5 to the 3x. I'm going to write that as 5 to the x cubed. You've seen me do that in class before. Minus 5 to the x raised to the 4. Same thing. Divided by 5 to the 5x. Or I could write that as 5 to the x to the 5, if you like. I don't like how this is becoming complicated, but I do like how I have the exact same power raised to the exact same exponent on the top in the numerator. I'm going to use my variable replacement and let a equal 5 to the x. If a is 5 to the x, then what this numerator becomes is a cubed minus a to the 4. And I know how to factor that. That's actually quite easy. It's not a difference of squares because a cubed is not a perfect square. But I can still common factor a cubed out and be left with 1 minus a. Once I've got that far, I can write this as a cubed, which is 5 to the x cubed, times 1 minus 5 to the x on the top. Now, on the bottom, I have a factor up here of 5 to the 3x, or 5 to the x cubed. On the bottom, I don't have that same factor, but I could. What we can do with 5 to the 5x is break it up into 5 to the 3x multiplied by another power, so that when we add the exponents here, what is 3x plus this adds to give 5x. Well, that needs to be 2x. 3x plus 2x is 5x. So what I've done is broken that up into two terms, two powers, with exponents so that I can reduce factors that give me the same value. 5 to the 3x and 5 to the 3x are reduced. So my final answer here, when all is said and done, is 1 minus 5 to the x divided by 5 to the 2x.